Hello, hi everyone. Welcome to the Student Brand. This is your Siva sir. Today topic is electric current. So let's get into the topic. Electric current. Electric current is nothing but rate of flow of charge. Hi, Aras sir. Hi. Welcome to the class. Electric current. I equal to Q by T. I equal to Q by T. SI unit of current. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of current is ampere. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of charge is coulomb, SI unit of time is second. Okay, so 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Okay, so now you can see here 1 ampere equal to 1 coulomb per 1 second. So electrons will flow, charges will flow inside of the conductor. If you are taking here, so this is conductor, so charges are moving inside of the conductor. Charges are moving inside of the conductor. Okay, charges will move. So will you say if only one electron is passing inside of the conductor, will you say current is passing? Only two electrons or two charges, three charges, four charges. So if five charges are moving inside of the conductor, will you say current is flowing? No. So number of charges. Okay. So number of charges are moving inside of the conductor, then we can say current is flowing. Current is flowing. Yes. So that's why I'm telling. So charge is a quantization. So here I'm taking Q equal to plus or minus Ne. Sir, why you're writing plus or minus Ne? Okay, so why you're writing plus or minus Ne? So here you can observe one thing. So charges, so positive charge is there as well as negative charge is there. Positive charge as well as negative charge. So both are moving inside of the conductor. Both are moving inside of the conductor. Only we can't say it's only one electron, two electron. So here charges are moving inside of the conductor. Charges are moving inside of the conductor. Those are positive charges are there, negative charges are there. Positive charges are there as well as negative charges are. That's why we are saying Q equal to plus or minus Ne. Q equal to plus or minus Ne. So we know current I equal to Ne by T. I equal to Ne by T. So on one electron, very important, on one electron, here on one electron, 1.6 into 10 power minus 19 coulomb. On one electron, 1.6 into 10 power minus 19 coulomb. Okay. So on one electron, how much charge is there? On one electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? We will discuss now. So here, this is the very important question. So they will ask one question on this one. They will ask one question in exam, in board exam. They will ask one question, that is, so on one electron, how much charge is present? On one electron, how much charge is present? Okay. So next one, in 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? So now you can see here. So in 1 coulomb, 1 by 1.6 into 10 minus 19. Okay. So now you can see here. Now you can see. So in 1 coulomb, 1 by 1.6 into 10 power 10 into 10 power 19. Okay. So in 1 coulomb, so 10 by 16 into 10 power 19. Okay. 1 coulomb, so 0.625 into 10 power 19. In 1 coulomb, 6.25 into 10 power 18 electrons are present. So in 1 coulomb, so this many electrons are present. Very important, very important. So remember this point. So I equal to Q by T. SI unit of charge, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Okay. So quantization of charge, Q equal to plus or minus Ne. I equal to Ne by T. On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19. That is, so if you solve this one, you will get it 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons, right? Yes, so these 2 points are very, very important. So remember everyone. So very, very important. One is electron and this one. So these 2 points are very, very important. So remember, you have to remember, right? So related to these 2 points, they will ask questions. Related to this point, they will ask questions. So now we will discuss about electrical appliances. Electrical appliances. Okay. So check once here. So first one is cell. Cell. Positive terminal, negative terminal. Second one is battery. Positive terminal. Cell I am taking here battery. Okay. Third one is switch. And the fourth one is closed switch. Closed switch. Closed switch and open switch. Open switch. And coming to the fifth one, resistor. Resistor. So I am talking about resistor. Here is a resistor. Resistor. And coming to the sixth one is rheostat. 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 Coming to the next one is ammeter. Seventh one is ammeter. Next one, eighth one. Eighth one, voltmeter. Voltmeter. Okay, voltmeter. Next one. Coming to the next one is ninth one is so wire joining. 10th one is wire crossing. 11th one is bulb. Okay. So here you can see cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing and bulb. Okay, so here you can observe. So open switch close resistor. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. And coming to the rheostat, rheostat is nothing but so the device which is used to regulate the current, the device which is used to regulate the current without changing the voltage source. The device which is used to regulate the current without changing the voltage source. Coming to the ammeter, ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. Okay, ammeter is connected in series combination. Ammeter is connected in series combination. Okay, coming to the voltmeter, voltmeter is a device. Voltmeter is a device which is used to measure the potential difference. Voltmeter is a device which is used to measure the potential difference. Voltmeter is connected in parallel combination. Voltmeter is connected in parallel combination. Coming to wire joining, wire crossing and bulb. Wire joining, wire crossing and bulb. Okay. I hope it is very clear. So this is about electrical appliances. Electrical appliances. Coming to the electrical circuit. Okay. Now we will discuss about electrical circuit. Electrical circuit. So electric circuit is nothing but electric circuit. Electric circuit. Electric circuit is nothing but a continuous and closed path of an electric current. So a continuous and closed path of an electric current is known as an electric circuit. So I am considering here, this is the cell. So battery I am taking. Oh, closed switch. Dot is there, closed switch. And so ammeter here I am connecting ammeter. So bulb. Okay, a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. First one is conventional current. Conventional current. Conventional current. Second one is electric current. Second one is electric current. Sir, conventional current. Conventional current is nothing but the flow of charges. The flow of charges. The flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current. The flow of electrons is known as electric current. The flow of positive charges is known as conventional current. Flow of electrons is known as electric current. Okay, positive charges will move from positive terminal to negative terminal, whereas electrons will move from negative terminal to positive terminal. Positive charges will move from positive terminal to negative terminal. Negative charges will move from negative terminal to positive terminal. So here is the conventional current. What is the conventional current? Conventional current is nothing but The flow of positive charges is known as conventional current. The flow of electrons is known as electric current. So conventional current will move from high potential to low potential, whereas electric current, electrons will move from low potential to high potential. Once again, conventional current is nothing but positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Conventional current and electric current. So here, very important, very important. So positive charges nothing but high potential. So positive cell has high potential, whereas negative cell has low potential. So positive charges will move from high potential to low potential, whereas negative charges will move from low potential to high potential. So this is about electric current. Okay, so based on this one question they will ask in exam. In the exam they will ask one question, that is so will negative charges will move from high potential to low potential or low potential to high potential? So explain. So they will ask one question on this one. So just know the concept. Next, I will explain about potential difference and electrical potential. Potential difference and electrical potential. Potential difference and electrical potential. Potential difference is nothing but, so here you can see, work done to bring unit positive charge. Potential difference. Potential difference. Potential difference. Potential difference is nothing but, so I am taking the conductor. Work done to bring unit positive charge from one point to another point within the conductor. So I am taking this a positive charge. So from point A to point B, so we are doing some work. V equal to W by Q. Work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. Within the conductor, if you are doing, that is called potential difference. V equal to W by Q. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point, that is called potential difference. Coming to electrical potential. Electrical potential. Electrical potential. Electrical potential is nothing but, okay, electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. So here I am taking the positive charge. Okay, so if you take this infinity, so I am taking this required field. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. V equal to W by Q. Same thing we can take. Same thing we are considering here. Here you can observe potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. I hope it is very clear, right? Next one, we will discuss about Ohm's law. Ohm's law, okay? So be ready for the Ohm's law. So now Ohm's law will discuss. So now we will discuss about Ohm's law. Okay, here so Ohm's law is nothing but worked. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay, so the potential difference across the ends of the given metallic conductor. So I'm taking this a resistor. So here I'm taking this a switch. So ammeter. Next one, 4 cells. 1, 2, 3, 4. So positive terminal, negative terminal, positive, negative. Here across the resistor, we are connecting the voltmeter. So across here, we are connecting the voltmeter. We am connecting here. Okay, so like here. So this is the point X and Y. Current is flowing. Through it. So the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. Okay, is it visible? Okay, done. Now you can see here. Now you can see. So here potential current is flowing through it. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. Okay, done. So now materials required at constant temperature. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. At a constant temperature only we are taking. At a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay, V is directly proportional to V equal to IR. Materials required. So what are the materials required? First one you can see here. Four cells of 1.5 volts each. 1.5 of each. 1.5 volts of each. Second one is nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire of 0.5 meter length. And coming to third one, so ammeter and fourth one voltmeter and coming to the fifth one, okay, ammeter, voltmeter. So 4 cells, nichrome wire, ammeter, voltmeter, switch and coming to the sixth one, So sixth one is connecting wires. Connecting wires. Connecting wires. Okay. So now first one, procedure. What is the process? Procedure to do. Procedure. First connect one cell. Connect one cell. Connect one cell and note down the reading of ammeter and voltmeter. One cell and note down the reading of ammeter and voltmeter. Connect two cells. Connect two cells and note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. Repeat the process for 3 and 4. 3 and 4. Okay, once again. First you have to connect one cell. Connect one cell and note down the connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay. Then you can mention in the tabular form given below. So I am drawing the tabular form. You can mention in the tabular form serial number, number of cells, ammeter, voltmeter, V by I form. 1, 2, 3. Serial number, number of cells, ammeter reading, voltmeter reading, V by I form, that is R. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this is a tabular form. Tabular form. So okay. Okay, now, so you can see here. So procedure, one cell, first connect one cell and note down the reading of ammeter and voltmeter and connect two cells. Okay, so repeat the process for 3 and 4 and draw so here VI graph. So you can see here. So V on y axis, I on x axis. The graph is linear. So this is for ohmic conductors. The conductor which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So here for non-ohmic conductors, the graph is curved. So V on y-axis, I on x-axis. So VI graph, the graph is for ohmic conductors. So VI graph is straight line for ohmic conductor, VI graph is curve for non-ohmic conductors. Okay, so ohmic conductors and non-ohmic conductors. Sir, why? What are the ohmic conductors and non-ohmic conductors? So the conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. First one is ohmic conductor. So this is for ohmic conductors. Ohmic conductors. Ohmic conductors. And coming to the non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. Okay, so for ohmic conductors and non-ohmic conductors, so you can see the graph. This is for ohmic conductors and this is for non-ohmic conductors. So you can see once again I will explain Ohm's law. Just focus on it. Here you can see Ohm's law, V is directly proportional to I. So the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. V is directly proportional to I, V equal to IR. Materials, 4 cells, 1.5 volts each. So here, how many cells? 4 cells, 1.5 volts each, 1.5 volts each, 1.5 volts each. Okay, so nichromire is an alloy of nickel, chromium, manganese and iron metals. And so ammeter, voltmeter, switch and connecting wires. So procedure, first you have to connect one cell and note down the reading of ammeter and voltmeter, and connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. So mention in the tabular form. This is a tabular form. Mention in the tabular form. So given. Okay. So draw the graph for VI. If you draw the graph for VI, so VI nothing but so V by I, if you give, that is resistance. Okay. Now VI graph gives the straight line for ohmic conductors. VI graph gives straight line for ohmic conductors. Curve for non-ohmic conductors. Non-ohmic conductors. I hope it is very clear. Sir, what is ohmic conductor and what is non-ohmic conductor? The conductor which obey Ohm's law. The conductor which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. I hope it's very clear, right? And now, so we'll discuss about one more. Resistance and resistivity. Resistance and resistivity. Okay, now, so we'll discuss about resistance and resistivity. Resistance and resistivity. Now here you can see resistance is directly proportional to length of the conductor. As length increases, automatically resistance increases. As length increases, resistance increases. So resistance is inversely proportional to area of the cross section. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. And R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. Rho into L by A. Okay. So rho equal to RA by L. Rho equal to RA by L. So rho equal to RA by L. Is it clear? Is it clear? Okay, check once here. Rho equal to RA by L. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by R equal to rho into L by A. So rho equal to RA by L. Best example, so you can take the pipe, so water pipe. If you take lengthy pipe, okay, so opposition will be more. If you take short pipe, so very short pipe, resistance will be less. So best example, one more thing if you take, so here water pipe if you consider, okay, area of the cross section is more, then easily water will go. So area of the cross section is less, resistance will be more. So R is inversely proportional to area of the cross section. R is directly proportional to length of the conductor. So R equal to rho into L by A. R equal to rho into L by A. Sir, here what is rho? Rho is a resistivity. Rho is the resistivity. So I am taking rho is the resistivity. 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 R is a resistance. R is resistance. Resistance. I hope it is very clear. So rho is a resistivity, R is a resistance. Rho is a resistivity, R is a resistance. Is it clear? I hope it is very clear to you all, right? So R is directly proportional to length of the conductor, R is inversely proportional to area of the cross section, R is directly proportional to L by A, rho equal to R equal to rho into L by A, rho equal to RA by L. So rho is the resistivity, R is the resistance. Okay, so resistivity, okay, so now we can go for SI unit of resistivity. SI unit of resistivity I'll discuss. So check once here. Resistivity. SI unit of resistivity. SI unit of resistivity. So rho equal to R. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter might get cancelled. Rho equal to ohm meter. Resistivity is equal to ohm meter. Resistivity is equal to ohm meter. Very important. Very important. 2 marks question. 2 marks question. So be careful. So 2 marks question. So this they will ask for 2 marks, and this entire derivation they will ask for 2 marks also. Okay, so make sure that you are learning this one. Okay, so very important. Clear? Right. Now resistivity is okay resistivity. Okay, done. Now definition of resistivity. So here definition I will explain. R equal to rho into L by A. Rho equal to RA by L. Rho equal to RA by L. Resistivity is equal to resistance of the conductor per unit length and unit cross section area. Resistivity is equal to resistance of the conductor per unit length and unit cross section area. So that is nothing but resistivity. Resistivity. I hope it is very clear. Right. Next one. So I'll discuss difference between resistance and resistivity. I will explain difference between resistance and resistivity. Okay, so difference between resistance and resistivity. So resistance depends on length of the conductor and area of the cross section. Resistance depends on. So fourth one. So resistance does not depend on. So resistivity does not depend on length and area. Resistance depends on length and area. Resistance depends on length and area. Coming to the fifth one. So it depends on temperature. Depends on temperature. And the fifth one. So resistivity also depends on temperature. Resistivity also depends on temperature. Coming to the sixth one. Resistance depends on material of the conductor. Resistance depends on material of the conductor. Resistivity also depends on material of the conductor, right? Yes. So here you can see resistance is R equal to rho into L by A. Resistivity equal to rho into RA by L. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. So very very important, 2 marks. Derivation is very important. So make sure that you are learning this one. And the resistance is SI unit is ohm, and here you know resistance depends on length and area. So length and area of the cross section. Resistivity does not depend on length and area of the cross section. Resistance depends on temperature and material. Resistivity depends on so temperature and material, right? Yes. Okay. So next, so we will discuss about one more. That is about now resistors are connected in series combination and resistors are connected in parallel combination. We'll discuss now. Resistors are connected in series, resistors are connected in parallel. So resistors are connected in series, resistors are connected in series combination. Resistors are connected in series combination. Okay. So now you can see here. So A resistor 1, 2, 3, ammeter. Okay, so current is flowing. Now you can see here. So here resistors are connected in series combination, means throughout the path current is same. Throughout the path current is same. So that's why IS equal to I1 equal to I2 equal to I3 equal to I. So current is same. Okay, so current is same I am taking. Now V equal to IR. So V equal to IR I am taking. Now you can see Vs equal to V1 plus V2 plus V3. So that is nothing but IRS equal to IR1 plus IR2 plus IR3. So this formula I took from Ohm's law. V equal to IR. So I is same. That's why I am taking I common. Now so IRS equal to I common R1 plus R2 plus R3. R1 plus R2 plus R3. So shall I cancel II? So I am cancelling. RS equal to R1 plus R2 plus R3. R1 plus R2 plus R3. So resistors are connected in series combination. Resistors are connected in series combination. So then the formula is Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. So listen carefully, observe carefully here. So all resistors are connected in series combination. All resistors are connected in series combination. Current is same throughout the circuit. Current is same throughout the circuit. So that's why Is equal to I1 equal to I2 equal to I3 equal to I. So from Ohm's law V equal to IR, from Ohm's law V equal to IR, I am taking Vs equal to V1 plus V2 plus V3, V1 plus V2 plus V3. So now IRS equal to IR1 plus IR2 plus IR3. I am taking common, I get cancelled. RS equal to R1 plus R2 plus R3. Okay. So I hope it is very clear. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. I hope it is very clear. So number of resistors are connected in series combination, Rs equal to Nr. So now we will discuss about resistors are connected in parallel combination. Now we will discuss about resistors are connected in parallel combination. So are you all ready? So let's start. Resistors are connected in parallel combination. Now resistors are connected in parallel combination. Okay, see here. So resistors are connected in series. Now, so we are discussing about parallel combination. Parallel combination. Okay, so now you can see here current is start flowing R1, R2 and R3. So I'm connecting here Okay, so V I am taking here. So potential difference Vs equal to Vp. So potential difference is same in parallel combination. That's why so Vp equal to V1 equal to V2 equal to V3 equal to V. So potential difference is same. Potential difference is same. Yes or no? Now you can see potential difference is same. From Ohm's law V equal to IR. From Ohm's law V equal to IR. I equal to V by R. I equal to V by R. I equal to V by R. So that's why IP equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. Right? Now V by RP equal to V by R1 plus V by R2 plus V by R3. Shall I take V common? So if you take V common, so V am taking common. So 1 by Rp equal to, so 1 by R1, V am taking common here. 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. So V will get cancelled. V will get cancelled. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the final formula is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is the formula. If n number of resistors are connected in parallel combination, so that is 1 by Rp equal to n by R. Very, very important formula. Very, very important formula. So based on this one question will come, and based on this one also question will come. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. If resistors are connected in parallel combination, this is the formula. So if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. Rp equal to, so what is the formula? Rp equal to R by N. Rp equal to R by N. I hope it is very clear, right? Yes. So this is about resistors are connected in parallel combination. So resistors are connected in parallel combination. So observe carefully. So I am explaining once again. Listen carefully here. Okay. So resistors are connected in parallel combination. R1, R2, R3. So current is start flowing. So potential difference across R1, R2, R3 is R. Okay. So V, R1, R2, R3 across R1, R2, R3 is V. So current is start flowing from Ohm's law V equal to IR. I equal to V by R. Potential difference is same. So that's why IP equal to. So current is passing through R1, through R1, through R1, I1, through R2, I2, through R3, I3. Okay. So if you want to get total current here, so we need to add I1, I2, I3. So that's why I'm taking IP equal to. So current in parallel combination equal to IP equal to I1 plus I2 plus I3 plus so I3, correct only, no? So V by Rp equal to V by R1 plus V by R2 plus V by R3. So V is common, right? So V I'm taking common. So V will get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if resistors are connected in parallel combination, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by Rp equal to N by R. Rp equal to R by N. Rp equal to R by N. I hope it is very clear. So this is about resistors are connected in parallel combination. I already mentioned resistors are connected in series combination. I hope it is very clear. Now, heating effect of electric current. Dun, 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 dun. Resist heating effect of electric current. Now we will discuss about heating effect of electric current. Right? Yes. Now heating effect of electric current we'll discuss. Heating effect of electric current. Heating effect of electric current. So heating effect of electric current. So we know potential difference V equal to W by Q. V equal to W by Q. W equal to V into Q. Okay, so rate of doing work. What is the rate of doing work? P equal to W by Q, electrical work. P equal to W by Q. So we know VQ by T. We know Q by T is I. Q by T is I. So rate of flow of charge is called electric current. Rate of flow of charge is called electric current. Okay, Q by T is current. Now, so P equal to V into Q by T, that is nothing but VI. So energy is given to the conductor. So with respect to time, so that is P into T, that is VI into T. We know V equal to IR. V equal to IR. Substitute here. Whatever the heat is, whatever the energy is given to the conductor, that will become in the form of heat. So H equal to, so IR into I into T. So H equal to I square RT. H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So this is about heating effect of electric current. Heating effect of electric current. Okay. So now you can observe here. So heating effects of electric current, V equal to W by Q, W equal to VQ, P equal to W by 2, VQ by T, Q by T is I. So P equal to V into Q by T, that is VI. Energy is given to the conductor, that will be in the form of heat. Okay, it will be converted in the form of heat. So E equal to P into T, VIET. So V equal to IR. So pH is given to the conductor, heat is produced. Okay, so heat produced in the conductor, that is H equal to IR into T, I into T, IR into I into T, that is H equal to I square RT, I square RT. So heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Yes, short circuit is nothing but the direct contact of live wire and neutral wire takes place, then heavy amount of current will be drawn from the mains. That is short circuit. Overloading is nothing but high voltage appliances on at a time. So high voltage appliances on at a time in the circuit, then heavy amount of current will be drawn from the mains. So it may lead to the short circuit. And so potential of live wire is 220, potential of neutral wire is 0, potential of earth wire is 0. Potential difference between live wire and neutral wire is 220. Okay, so frequency in India is 50 hertz. Okay, so this is about live wire. So positive terminal, negative terminal. And coming to the fuse, fuse is a safety device. So which melt and breaks when exceed current. So the current is going inside of the circuit than required limit, then it melt and breaks the circuit. It is a safety device. Okay, so it melt and breaks the circuit. And coming to the fuse, earthing, extra current is there, that will send to the ground. Okay, so if extra current is there, that will send to the ground. So this is about safety devices like a fuse and a earthing, and fuse and earthing. I hope it is very clear, right? So right from starting electric current until heating effect of electric current and heating effect of electric applications. Heating effect of electric current applications. What are those? So electrical oven, electrical cooker, so iron box, room heaters. So these are examples of heating effect of electric current. Okay, the source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. Heating effect of electric current is also known as Joule's law of heating. Joule's law of heating, right? So thank you so much. This is Vasar from Student Brand. Thank you so much for joining and attending and listening my class. This is your Shiva sir from Student Brand. If you like the video, do like, share and subscribe to Student Brand. If you like the content, you can share to your friends, ask your friends to join to the class. Then we'll see in the next class. This is your Shiva sir from Student Brand signing off. Thank you.